Okay, so far we have discovered the negative transformation function, whereby the negative transformation function is under linear transformation functions. Okay, let's get back to our overall mapping over here. Okay, we already discussed about the image enhancement, and then okay, we already discussed about the image enhancement, and then we talk about what is spatial domain. Okay, image enhancement in spatial domain. And then in this chapter again we talk about the point processing, whereby the point processing is divided into two, which is gray level transformation function and histogram. Okay, and again, like I said, in our discussion we always talk about T. Okay, T, which is transformation function. So the T over here does not always mean anything related only to point processing. Okay, but it's also related to anything that related to spatial domain. Okay, meaning that if you talk about the negative transformation function, okay, actually is under, okay, it is under linear transformation function. Again, under linear you have identity transformation function. Okay, identity transformation function, you have negative transformation function, and then later we will cover the another transformation function, which is power law as well as logarithmic. Okay, I just put that as a log. Okay, and then after that we will cover as well the histogram processing. Okay, histogram processing is also dealing with transformation function, but it is the transformation function is generated based on the histogram information from the image. Okay, still you are using transformation function. Same goes to the neighborhood processing. Okay, it's also dealing with transformation function. Okay, just don't get confused with that later, because everything that dealing with spatial domain, image enhancement in spatial domain, is dealing with transformation function. Okay, the difference is just how actually we get that transformation function, and what is the form of transformation function involved in that topic. Okay, now let's get back to our chapters there. We already discussed about okay, about the negative image transformation function. Okay, I just draw the thing involved there, which is, yeah, this whiteboard. Yep, this one. Okay, so again, this is the three basic transformation function in point processing. Okay, you have logarithmic, you have power law, and you have linear transformation function. Okay, and I skip off discussing about the this one, which is yeah, this one, identity transformation function, because if you write the equation, of course, if we talk about the negative transformation function, which is this one, okay, the equation is S equal, okay, TR, and then S should be equal to L minus 1 minus R. That is a negative transformation function. However, for identity transformation function, the equation is just S equal T, or T of our R, and actually S is equal to your R, meaning that any value here, okay, any R here, let's say this is R1, okay, you will get the same as S1 over here. Then the S1 should equal with R1. Okay, the S1 is equal to R1. So meaning that this transformation function is not so meaningful in doing some process. Meaning if you process the identity transformation function to certain image, that you will get the same image, okay, the same intensity. So there's no enhancements there. But identity transformation function in certain application have been used to derive in certain equation. Later you will see where actually the identity transformation function involved. Okay, and next discussion we're going to talk about these two, which is logarithmic transformation function and power law transformation function. Okay, in logarithmic you have a log, you have inverse log, and then power law you have n's root and n's power. So actually if you see the shape there in terms of mapping between R and S, the shape of the transformation function is almost similar between the logarithmic and power law, and later the discussion also you can see it's quite similar, the explanation in terms of the characteristic of both logarithmic transformation function as well as power law transformation function. Okay, log transformation function, if you read through this slide, it explains that the log transformation function will maps a narrow range of input, okay, low input gray level to wider range of output gray level, and map a wider range of high input gray level to the narrow range of output gray level range of output gray level. Okay, to understand that two statement there, okay, you need to identify the words there. Okay, map the log transformation function map narrow range of low input level. Okay, to understand these two statements, you need to identify that region. What is the meaning by low input and high input? Okay, let's go back to our slide there. I'm sorry, to our whiteboard there. Okay, this is a logarithmic. Let me zoom a little bit, this one. Okay, this is logarithmic. Okay, again, if you talk about 8-bit intensity level, 8-bit per pixel, intensity level resolution of 8-bit per pixels, then your R should be from 0 to 255. Okay, same goes to this one, from 0 to 255. Okay, what is the meaning by low inputs there? Is the any region which is have the lowest number, which is this part. I considered half of this one, can consider as our low input. This one is low input or low intensity value. That's why they call it low input. Okay, why they call it input? Because R is your input of the function or of the transformation function, and the one that, okay, another name for low input should be dark. I call it as a dark region. Why I call it dark region? Because from 0 to 128 here, okay, half of 255 is 128, is something which is close to the dark region. Okay, because 0 is black, then the one, any intensity value which is a smaller value should be towards to the dark region, while above 128, which is this part, okay, this is just a roughly estimation, we can consider as the high input, and other word for this one as well should be bright. Okay, why we call it a bright region? Because of this value will actually represent the bright color, okay, towards 255, where 255 is your white color. Okay, so that's why we call it as a bright region, and this one is dark region. So back to this statement. Okay, you back to the slides there. Okay, the log transformation function will map the narrow range of input gray level to the wider range. Okay, why they said log transformation function will map the narrow range of input into the wide range, okay, low input. So if we talk about the low input, this it's belong to this part. So let's say I put a narrow range there. What is the meaning by narrow range in that statement? Okay, you just put any narrow range. For example, I put this point, it's very narrow, but when I map, yeah, it's very sorry, not this one, let's go this one, because log is your green, okay, it's a green line, it's not this one is anti-log or inverse log. Okay, I put some narrow range, I put this one, okay, it's very narrow, Okay, the line there is very narrow. It's very narrow over here. I put two limits there, represent two very narrow line. If I map into log transformation function, okay, so I find out that okay, now the range of our output there, which is this one, is very wide than this one. Okay, let's go to let's say other example. Let's say I put this one, a very narrow there, but when it come into output, it's very wide. Okay, the range is very wide as compared to this one, which is very narrow. Okay, this one is very narrow, but this one is very wide. So that is the meaning of that statement in the slide there. As you can see, if you talk about the log transformation function, it will map a narrow range of low input grade level. So that's why I draw a narrow range under region of low input. Okay, low input, which is this one. So what is the meaning by low input is this region. So I just map the narrow range there into the output, and I find out that now it's become very wide range at the output side. Okay, so that is the meaning of this statement. So a second statement is another way around, meaning that if you map the wider range of the high input, it will become very narrow at the output side. Okay, for the second statement, it's talk about the bright region over here, or it called as the high input. So as you can see that for that statement, okay, if you go back into that slide over there, okay, it will map the wider range of high input grade level to a narrow range. Okay, the second statement, what is the meaning by this second statement is that for the high input, okay, if you talk about the log transformation function, okay, it will, if you have a wide range at the bright side or the high input, okay, if you map into log transformation function over here, okay, what you get at the output side is very narrow. Okay, which is very narrow over there. So that is what I mean. The second statement is work another way around as compared to the first statement, because the first statement, if you talk about the log transformation function on the dark region or the low input, it will stretch the dynamic range from narrow to wider range. Okay, that's why you can see very small there become very wide. But if you talk about the high input region, it will compress from a wide range into very narrow range over here. Okay, so that is the meaning by that second statement. Okay, again, this is for logarithmic transformation function. For inverse transformation function, it works another way around, meaning that for inverse transformation function, if you talk about on the input at the low input, it will narrow down from the wide to narrow, and if you talk about the bright side, it will stretch, or it will make a mapping from the narrow range into wider range. Okay, it can be proved by mappings there. Okay, if you have a very very wide range, something like this. Okay, this is your range. If you map here, it become very narrow at this side. Okay, but if you map over here very narrow, at the end you end up with very wide on the output side. So it's another way around as compared to logarithmic transformation function. Okay, but that is different between the log and inverse log. Inverse log, you are stretch the bright side or the high input, but for the dark side, you are compressing the range. Okay, and for a logarithmic transformation function, you are compress the the bright side, but you are stretch the range at the dark side. Okay, so I hope you clear about that